Hi, everyone, and welcome to the HYPACK LiDAR Payload webinar. My name is Brittany Hines, Marketing Specialist here at HYPACK, and I will be your host for today's presentation. Before we begin, I just want to remind you about the question box on the side of your screen. We will be taking questions at the end of the webinar, so please submit them using that drop-down box. Also, if you're unable to hear us or the screen goes blank, please comment in the chat box so we can fix the issue. So for today's webinar, we are going to talk about the HYPACK LiDAR Payload and how we're here to support your survey needs. I would now like to introduce to you our presenter for today, Hannah Marshburn, who is our sales representative and unmanned systems lead here at HYPACK. We're so happy to have her here with us today to give us some handy tips and tricks and also an operational tutorial. So with that, I'm going to turn over the presentation to Ms. Hannah Marshburn.
Hi, everyone. Thanks for joining us today. This is our second webinar on the LiDAR payload. And if you were with us for the first one, this one's going to be a bit more technical. I'm going to go over the basic specs of the system, some operational tips and tricks to give you a good idea of how the payload works. And then we're going to talk about some of the data and discuss some of the reasons why we're excited to present this product to you today. So first of all, I want to talk about why HYPACK is excited about using LiDAR in our surveying toolkit. LiDAR is a quick and accurate way to obtain historically difficult data. Shoreline data can often cause surveyors to operate in navigationally hazardous areas. You may have to run a survey boat around a rocky shoreline at low tide to try to site and get position on some obstructions and hazards, or you may have to wade through some difficult tidal area or walk some difficult or vegetation heavy areas. So LiDAR can capture data quickly and efficiently and allow you to get all of the important data for your surveying needs. LiDAR is also really good for thin edge features. It can capture edges of buildings and power lines and does a really good job at those thin edge features that some other similar methods of surveying like photogrammetry can struggle, and they will require repeat captures. LiDAR can also penetrate through forest canopies and dense vegetation really well. Photogrammetry often would require you to do a few takes to get that data. And as hydrographers or surveyors, we usually have all of the necessary sensors you need to operate a LiDAR survey. We all have GPSs, computers, are familiar with wiring things, and that's all you need to run a LiDAR survey. So it integrates really well with our other workflows and our existing toolkits. LiDAR also has very little processing, as we'll show you later today. So it has a really quick data turnaround compared to some more computationally heavy methods like photogrammetry or the tedious aspects of cleaning data from sonars. It's also really low cost compared to traditional methods. One sensor is a lot more affordable than running an entire survey boat or putting a whole crew in the field. So overall, LiDAR will increase efficiency, reduce risk, and we're excited to have a tool to help you do all of those things. So our goal here at HYPACK is to create an affordable and functional LiDAR package for our customers. And we really think we have achieved that with this new product. We're also aiming to do a lot of the work behind the scenes. So we're working really hard to pre-calibrate and pre-configure every unit before it's shipped to you, the customer. This will allow you to get in the field quickly and reduce stress and reduce training for your staff. We hope that our payload can help you integrate LiDAR into your workflow as seamlessly and as painlessly as possible. Some potential applications you can use LiDAR for, or shoreline or obstruction charting for navigation, mapping streams and channels, as some aspects of HYPACK and Xylem work on often. You can do infrastructure assessments, beach erosion surveys, vegetation surveys, some sort of bare earth analysis, A lot of folks often contact us about doing construction site analysis or estimating volumes removed from quarries and mine analysis. So now I'm going to go into a few of our payload system specs so you get a good overview of what to expect in our HYPACK LiDAR payload and the performance of all the sensors included. So in summary, the payload is a complete and standalone LiDAR surveying toolkit. As you can see, the Valentine VLP puck light is mounted on the front of an enclosure. The enclosure is IP67 rated, meaning it's dust-proof and somewhat waterproof. You supposedly can submerge the unit up to 1 meters, but we wouldn't recommend that because you have a lot of exciting sensors within the unit. Inside of the unit, you'll find a sliding computer rack that has an SVG Ellipse 2D system. It's a mini GNSS INS. It's a compact inertial navigation system with an integrated dual antenna RTK GPS. It's really lightweight and easy to use, and we love working with this product. Nested between the computer rack towards the front of the system, close to the Valentine, is a small internal battery that, when it's fully charged, has a 3-hour runtime. As you can see, there's also antenna arms that are attached to the side of the unit, and those extend and retract. All of this comes in a Pelican case for secure transport that houses spares. And inside of the unit, there is a Minicomputer. It's a Pico 500, and it runs Windows 10s with HYPACK Max and High Sweep. So you need a HYPACK Max and High Sweep license to run the unit, and we've included it with the payload. So the key capabilities of the unit, it's a fully contained LiDAR data collection system. So you don't need anything else in the field when you're running this unit. It provides you with all the necessary sensors. It's a complete standalone solution. The antennas extend to a fixed offset of 1 meter, which eliminates the need for any repeat calibrations. It can be mounted on any vehicle platform, including drones, cars, you name it. We've tried really hard to make this as platform agnostic as possible. The system weight is 10 pounds, which can fit on quite a few industrial drones. There's a few out there that can lift 10 pounds and over, and I have a list here for you at the bottom. Most of these drones have carbon fiber poles that are attached to the bottom of some sort of center console, and we have a mounting system that attaches to the drone to easily clamp onto those carbon fiber mounting poles. So here's a glimpse of what the finished product would look like. As you can see, the payload itself is nested in the Pelican case inside of a custom foam insert. So you'll, of course, the payload will come with the payload itself, all of the sensors. We also include a battery charger, which is compatible with the regular AC wall outlet. We have spare screws and hardware in case anything comes loose. We have a mounting system for UAVs. Like I just mentioned, you can see those 4 sort of circular mounts that are attached to the top panel. Those are what clamp onto carbon fiber poles that would be on the center console of a drone. We also have a U-shaped mounting bracket that attaches to that top panel as well. The U-shaped mounting bracket is really nice because it gives you a flat surface to mount the system onto. At HYPACK, we like to test our payload with our HYPACK van. We have a flat board that attaches to the top of the van, and we simply attach the unit to that, and it provides a nice, flat, steady surface for surveying. We also have some unit documentation, which includes our quick start tutorial and some really important lists of all the IP addresses of the sensors included in the unit. I mentioned that everything's going to be pre-configured and pre-calibrated before it's shipped to you, which is true. So all the IP addresses are going to be pre-populated, but you'll also have this documentation as a reference in case something goes wrong or you just need to look something up yourself. So the Valentine puck light is a really popular LiDAR sensor in hydrographic surveying. It's got a great price point, a measurement range of up to 100 meters, accuracy that can be as high as 3 centimeters. It's lightweight, 590 grams, a dual return system, and it's class 1 eye safe, so you don't need any special PPE to operate. this LiDAR sensor. We've used it a lot at HYPACK over the past couple years and helped a lot of our customers integrate this into their workflow. So it's something we're really comfortable with and does a great job. We have a driver for the Valentine and HYPACK. You can enable or disable all 16 channels. We usually like to operate a few channels around the center point of the system to get good data close to nadir. We have an angle and a range filter where you can set minimum and maximum elevations and filter out low elevations that can introduce noise, like if you're getting reflection off of a boat deck. We also have angle filter, which keeps data within a specified angle set. The Ellipse 2D is a great little mini INS system. It can measure roll and pitch over 360 degrees to within 0.1 degree. It has dual antenna heading system, a 5 centimeter real-time heave filter, and capable of receiving RTK corrections. And it's super lightweight, great for UAV applications. Okay, so now I'm going to go into our quick start procedures and introduce to you some of the important concepts to remember when you're operating our system, to give you an idea of how it's configured and just what to expect. So this is a picture of the back panel of our payload. As you can see, there's an open USB port and an open Ethernet port. There's also a red power indicator. When this switch is flipped on, a red light will illuminate, indicating that the unit is turned on. All you need to do to turn on all the sensors inside the unit is flip this switch. All of the other sensors will initialize. The switch turns on the Valentine, the SVG, and the Minicomputer. So it's a real nice and easy way to start the system. I also have here the hinge pins labeled that you open to extend the antenna arms. You open those spring pins, extend the antenna arms, guide the spring pins into place, which will securely hold the antenna arms so you can survey at altitude with the UAV without worrying about your antennas moving and affecting your data. While the power indicator turns on all of the sensors, you, the user, do have to initialize the software. There's a real easy way to do this. We at HYPACK use a field laptop and the available Ethernet port. We connect our field laptop with the unit computer through that Ethernet port, just plugging your laptop in. And then you can use a Windows program, remote desktop connection, to open the computer, the internal computer of the payload. So this is just found in your Windows programs. You open remote desktop connection. The IP address should be pre-populated, but again, it'll also be listed in the documentation, so really easy to find. So once you connect to that internal PC via remote desktop connection, the first step you would take is open the SVG Center to initialize the software for the SVG. So once you open that, make sure you have a connection with the unit itself. Take note of the COM port and your baud rate for the unit. I have this screenshot of settings up here for you because I want to tell you that we will pre-measure your lever arms and your offsets for each unit before sending it to you, the customer. One reason for this is because the reference point of the SVG is inside of the system. So in order to save you the hassle or the stress of having to open the system up and do the tedious work of measuring offsets, we've pre-populated these settings for you. So those will be saved in your SVG Center settings and ready to go. One thing to note is that while we have pre-populated the lever arm offsets, you will need to pay attention to the way you have the unit oriented or mounted. You'll have to change alignment options based on your mounting orientation. You remember that the Valentine is mounted in the front of the unit. So if you mount the system with the Valentine forward facing, the primary lever arm on the y-axis would be to the left, which is standard practice. And then the x-axis would be back, running backwards from the Valentine towards the antenna arms, and the z-axis will be down. If you want to flip the unit around so the Valentine is rear facing when you mount it, which is common for a lot of hydrographers who are using LiDAR on their boats, the y-axis is going to flip around and be to the right. The x-axis is forwards, z-axis is down. So you have to switch some signs around. Again, it should be very straightforward, just something to keep aware of when you're operating the unit in the field. I have here the GPS outputs for you to look at, and I wanted to mention this because the SVG is really the lifeblood or the heart of the entire payload. Data is coming in through the SVG, and data is being fed out to all the other sensors on board from the SVG. So port A is the SVG sending position or motion and position data to HYPACK. This is where you also set the frequency at which you can log raw GNSS data. Port C is open for RTK corrections coming into the SVG. And then port E is sending PPS timing and position to the Valentine. So if something is wrong with the payload, it is likely going to be here. It's really important to keep all these channels of communication open. Data is flowing in, data is flowing out. So finally, for the SVG, some important overall GPS checks. You want to open up your device status and your GNSS status and make sure you at least have a narrow lane RTK GPS status. You want to make sure that your alignment status is aligned. So if your alignment is not aligned, like it is here in this image in the top right corner, it just means that the internal sensors and the INS need to calibrate. It's really easy to do this. You just need to move with the unit, move slowly. You can perform some slow figure eights, like if you're performing a GAMS calibration, and the internal sensors should align. You also want to make sure that your solution mode is in full navigation. The next step to initialize your software is to open the Vella View software, which starts the Valentine. You want to select the Valentine 16 from the list of sensors that opens, and data should populate the Vella View window screen. You can also use a web browser to type in the IP address of the Valentine to make sure that the Valentine's receiving position and that the PPS solution is locked. Just means that the Valentine is getting timing from the SVG and you're ready to open HYPACK. One important thing to note is the way in which you can establish a Wi-Fi connection with the payload. We at HYPACK have a real easy way that we like to do this. There's an available USB port in the back panel, and we've simply just been using that to tether a smartphone, which is a tool that almost everyone already has. So you can just plug a smartphone into the computer, make sure you have the compatible settings loaded on your phone or on the computer, and you should be good to go. You can also use a mobile air card or any sort of Wi-Fi device that's powered by a USB hub. Again, this is great because it doesn't require any additional equipment. Of course, you'll need to secure your iPhone or your Android if you're using the phone method, but it's a really easy way to get Wi-Fi into the unit. It's important to get a Wi-Fi connection if you want to use RTK corrections, which are really recommended for collecting LiDAR data. It really helps to bring that data into survey grade accuracy, and I'll show you an example of RTK data applied to our sample data set in just a bit. So in order to get RTK, you need to have Wi-Fi, and we use a field laptop as a VRS station to broadcast N-trip connections using the Wi-Fi. And it's also important to note, we will not provide to you an N-trip account or software if you're interested in purchasing one of these units. It must be sourced by you, the customer, independently. But we know that most of our customers already have RTK methods they're really comfortable using. So we're hoping that this is a real easy way for everyone to use their own methods with the payload. We also have a new software module called Input Echo. This is going to be pre-installed on your payload PC, and it is not operated within the HYPACK shell. It's just another software module on the desktop. It's basically a raw data logger to log all your GNSS data for post-processing if you wanted to use an SVET to apply to your data. You would need SVG software inertia to do that, but We've written this program so you'll have all your raw data. It's really easy to use. You just need to set up your project directories and make sure that you have a compatible baud rate and serial port that you set up in your SVG Center settings. It's also important to note that when input echo is running, it's broadcasting data from the SVG to HYPACK via a UDP port. So just good to know that you want to keep that channel of communication open. You would also want to start logging these files 5 minutes before serving and end it 5 minutes after serving, just like you're collecting data with a POS-MV before serving on a vessel. Okay, so now we're going to go into some project setup modes in HYPACK and then get into data examples. So one of the things we are most excited about is sending a sample project out on every PC. So this is going to be pre-installed. Now I know that setting up HYPACK hardware might be your favorite thing to do when you're operating HYPACK, and I'm sorry to take that away from you, but I think this will make it really easy and reduce stress and training for your staff. It's a really easy hardware setup. You just need the SVG for survey to send data to high sweep. You need to enable high sweep and load the Valentine vertical driver and an SVG driver in high sweep. I have the Valentine driver open here because I also wanted to mention that we will pre-enter the Valentine offsets. So the Valentine is mounted a bit forward of the SVG on the system. So we're going to have that pre-measured for you. It's also mounted at a 270-degree roll angle. So all of that data is in here. You don't have to worry about any of the tedious work that comes with measuring offsets or setting up a system. Okay, so data acquisition. So we'll give you a sample hardware project, and then you just need to do all of the normal pre-serving background work. Maybe you want to load some charts. Maybe you want to set up a matrix, and then you can launch high sweep survey. And we have a short video here to show you what data acquisition would look like with the payload. So you can see here, HYPACK real-time cloud is open to the right. Data is populating the screen. We have some nice point cloud data coming into view. We're going around a steep bend here. You can see it's picking up the power lines, the edges of trees. We're coming around the bend of a church. You can sort of see the steeple, the defining feature of that building clearly. In the bottom left corner, we have our topographic laser driver. This will give you the rough elevation data of all the data coming in through the LiDAR payload. We have our map window open where you could set up your line plans or monitor your matrix. And then the survey and high sweep drivers so you can check your GPS data and take note of any spikes or things that you would want to write down for processing. So similar to running a survey with any type of sonars, all the same tools. And real-time cloud really helps you see the data coming in a tangible way. All right, so now we're going to move into some data processing. So you need a HYPACK Max high sweep key because you need to operate MBMax 64 to process LiDAR data. So just like if you're processing multi-beam data, you're going to load your HSX files into MBMax 64. And I opened the read parameters here just to remind you that you don't need to enter any additional offsets. That's all pre-done for you. The only thing that's entered here is that roll value. So one thing we like to do is just check our raw speed. And then at the bottom, I have tide and heave values. So you can see here that there's a couple of spikes. Maybe we went around a turn too fast. And then we have a little bit of a dip in our RTK tide values. So that'll be something to check out in the data set. And then here we have an overview of the heave, pitch, roll values, so all that data from the SVG for you to take note of anything that you might want to check out in your data. So here's the raw data loaded into MBMax64. It's displayed as point cloud data, which can make LiDAR data seem a little bit more logical rather than a matrix. Sometimes in a matrix, data is interpolated between points, which is helpful when you're covering a large survey area for hydrographic work. But for topographic LiDAR data, point clouds can be really helpful. So as you can see here, here's that same data just displayed as a matrix instead of a point cloud. So there's a lot of interpolations and it seems a bit overwhelming, but as soon as you view the data in a point cloud format, it makes a lot more sense. So after we've edited out some of our data, you can see that the largest spike in the speed data is gone. We still have a little bit of a bump in our RTK tide value, which is corresponded to just going around a turn. It's just a bump of about 4 centimeters. And then the heave, pitch, roll values look quite similar. We performed a patch test, which we don't have time to go through today, but you can see those patch test values are updated and saved in the read parameters. And we're going to apply those to our data set. And then we're going to show you another one of the ways we like to edit our LiDAR data, and that is by using our real-time cloud program. So real-time cloud can be found directly in the HYPACK shell. You don't need to go into MBMax64. We have our fast delete mode on, and we're just going to go through and update some of the peripheral data points, just like you're deleting noise or bad data points from a hydrographic data set. So real easy to do. We're going to trim out some of the edges of this data so we just have the features we're interested in. Next, we're going to talk about applying SVETs to LiDAR data. So after you edit out any data points, you applied your patch test values, you can apply SVET data, which can help tremendously, as I will show you. So I mentioned that you will need Inertia, which is the SVG processing software to produce an SVET, and you will need to load an SVET in MBMax64. So we're gonna zoom in on this church steeple. So you can see there's some noise in front of the steeple, but it's a great feature for patch testing or looking at how an SVET can improve our XYZ position data. So under Tools, Pods Pack Adjustments, we're gonna look for the SVET file that's been loaded into our project. Select that file and apply. So we're updating all of our data points. And then we're gonna bring our cells up to date. Using the cloud tool, zoom back in around that church steeple. And you can see it really pulled those data points in a lot. There's no more noise around the steeple. The front of the building has been pulled in nice and tight. We can see the roof in great detail. And it's looking pretty great. All right. So we're going to look at a few other ways to view a data set in HYPACK Real-Time Cloud. My mouse here, there we go. So cloud, you can locate cloud and under the utilities tab in a shell. We're going to load an XYZ file. You can save XYZ files or export XYZ files from MBMax64 or cloud. Loading our data points here. Okay, so one thing to note is that you can view your data points in depth or elevation. As you can see, those numerical values are all negative. Usually when we talk about depth, the number increases as the depths grow or get deeper. So the inverse is true for elevation. As you get higher in elevation, you're going to have a greater negative value. So you can see we're applying a custom color scheme here. And this will just help you get a better idea of the height of the trees and buildings, and just another way to view your data. Zooming in here on the side of this building so you can see that we can accurately place the elevations of the building. Now we're displaying the point cloud with depths and intensity values. So intensity is another type of data that is written into or recorded in your raw data file. It can help you figure out what sort of surfaces you're looking at. Here you can see that the street or the asphalt has a darker value than the buildings or the grass. Asphalt has a high absorptivity, so it's going to have a really low intensity value. So if you're doing some sort of vegetation analysis or some sort of volume analysis at a construction site, looking at intensity can be quite helpful. And here is intensity displayed by itself. Some psychedelic coloring, but it can serve a really useful purpose for certain types of analysis. Okay, so in just a minute, we're going to load a GeoTIFF into real-time cloud. HYPACK can pull the RGB color bands from a GeoTIFF and apply those to a point cloud, which just creates a real nice, realistic looking picture. So we sort of have a black and white color scheme here, but this can be really helpful. Make your data make more sense. Okay, so in summary, this is the feature we looked at extensively over the past couple of minutes. The top image is a Google Earth image of St. Catherine's Church in East Windsor. The bottom image is our 3D point cloud. It matches really well. We were able to see the front of the church in great detail, the steeple. We like to use this example because it's a hard to capture feature with LiDAR data, and our payload did this really well. So we think it will have a lot of great potential to do whatever sort of work you need it to. So again, some potential applications for payload. You could use it for shoreline charting, pipeline mapping, some sort of infrastructure assessments, looking at beach erosion surveys. Those intensity values can be really helpful. Vegetation surveys, bare earth analysis, or looking at volumes, construction sites or quarries, or any sort of mine analysis you may need to do. And in summary, we're really excited about the LiDAR payload. We're doing a lot of work behind the scenes to really make it as easy as possible to use for you, the customer. We also have that nice Pelican case for ease of transport. It's a real standalone surveying kit. You shouldn't need anything else except maybe your smartphone for Wi-Fi. We're going to have everything pre-configured and pre-calibrated to reduce stress and training, and hopefully reduce expensive field time. We've outlined our quick start procedure for you and in a few different places. and data processing should be really painless, so you should be able to have a quick data turnaround. And one of the most important things about our payload is we're trying really hard to make it affordable. We want you to incorporate LiDAR into your surveying toolkit while staying within budget. So we're increasing efficiency, reducing risk, and staying within budget. And that is the end of the presentation, and now we'll have time for some Q&A.
Thank you, Hannah. That was a great presentation. We hope that gave everyone a better understanding on how the HYPACK LiDAR payload works and can better help your projects. Now we will move into the Q&A section of the webinar. So we hope you stick around for this section, but if you're unable to, we want to thank you for joining us today, and we hope to connect with you in the near future about the LiDAR payload solution. So we're going to answer all of the questions, but if yours does go unanswered, we will follow up with you via email over the next few days. Okay, so question number 1. Can I use an existing HYPACK software license?
Thanks, Brittany. Yeah, you can. Included in a purchase of the payload is a new HYPACK Max and High Sweep license, but we're totally willing to work with people's existing HYPACK license. You know, whatever they have, we want you to use what you have, and we're totally willing to work with you.
Okay, the next question is, to what water depths does the LiDAR penetrate?
Yeah, so this is actually just a topographic LiDAR unit. We hope to work with some partners on offering some sort of bathy LiDAR solution potentially in the future, but this particular unit is just for topographic work.
Okay, the next question is, can I process an SVET in HYPACK?
So good question. You actually need to purchase a commercial license, which is SVG's processing software to process an SVET, which is really easy to do, and they're a great team to work with. But if you contact us at HYPACK, we can help you get set up with that.
Okay, the next question is, this person said accuracy 3 centimeters at which distance?
Yeah, so the range is said to be within 100 or up to 100 meters. I've found that the accuracy, I would say it's best up to 50 meters. So you could expect, you know, best case scenario, 3 centimeters up to 50 meters.
Okay. The next question is, what is the overall accuracy considering all systems integrated?
Yeah, good question. From our internal tests, we've measured it to match about 3 centimeters. And whoever asked that question, if you contact me directly, I'd be happy to share all our data points with you. But yeah.
Okay. Next we have, are RGB colors recorded at acquisition?
Oh, yeah. So we, at the moment, don't have a camera on board to record those RGB colors. So you would need to, you know, use some satellite imagery to get a GeoTIFF, which is easy to use, and you can import satellite imagery into HYPACK to georeference that data for you. But we have been working on attaching some micro cameras to the unit to hopefully offer that modification in the future.
Okay, and we actually have another RGB question. Where do the RGB colors come from?
It's something that's recorded in the GeoTIFF, but like I said, HYPACK can't actually record those values without a camera driver. So right now we don't have a camera attached to the payloads. You would have to use satellite imagery, but hopefully we can offer people a camera modification and a driver in HYPACK to collect that data in the future.
Okay. Where is the data logging at the payload or computer at the operator site?
So all the data is going to be stored on the internal computer of the payload. But it should be easy to extract. Again, you can hardwire via an Ethernet cable, plug your laptop into the computer to pull that data off. And we've put quite a bit of RAM on the computer. So, you should easily be able to survey for 3 hours, even though it is a small microcomputer.
Okay. And what is the maximum recommended height for this LiDAR?
That is a good question. So the range is up to 100 meters, but I think, so you could potentially go that high. It would just be up to your testing standards. We have done a lot of testing in the past at around an altitude of 40 meters. And it tends, to get great data at that height.
Okay. Next question is, what's the IP rate of the whole product?
So the external enclosure is IP67 rated, and I believe the Valentine is, but I would need to double check on that. So I can contact you directly, or if you want to contact sales@hypack.com, I will check on that and then let you know. But besides the Valentine, the system is IP67 rated.
Okay, everyone. Well, we're unfortunately out of time, so we're going to wrap this up. There were some unanswered questions, but we are definitely going to email you all of your answers. There was also a lot of questions about price of this product, so we encourage you to reach out to Hannah and our sales team. We are here to answer all those types of questions, and we want to thank you for your participation and hope you enjoyed the webinar today. So don't hesitate to contact us. And please check us out on our social media pages, Facebook, Twitter, LinkedIn, for upcoming news and updates. And we hope to talk to you soon. Have a great rest of your day.